315. We start here. We go past 90, past 180. The next guy is 270. So then I know that somewhere in this quadrant, this is 1, 2, 3. This is the fourth quadrant. So somewhere in the fourth quadrant is going to be my 315-degree angle. I need to know how much more than 270 or how much less from 360 is that angle, and the answer is 45. So I'm going to end it at about what I think looks like 45. That is a 315-degree angle. So then remember that my right triangle has to be built off of the x-axis. Solving for that angle, you would, however you would like to do it, 360 minus 315 or 270 minus 315 and then make it positive, but either way, we'll figure out it's 45. Labeling my side lengths appropriately. The x value here is positive, but the y value is negative, so I'll make that -1. And then now I can answer my question. My question asks for sine of 315. So it's going to be opposite over hypotenuse. It's going to be sine of that specific 45-degree angle. Again, calling it 45 prime, just to further emphasize that it's not actually sine of 45, but of this 45. Opposite over hypotenuse. And then rationalize the denominator. So then that is going to be what sine of 315 is. So since these numbers do not add up to 180, their values are not the same. Sine of 45, a real sine of 45, is the positive square root of 2 over 2 because it would be built in this quadrant, like that, right? Meaning that the opposite side length would be positive, making the sine value positive. So when your angle is greater than 180, it's not its supplement, but the angle that helps it add up to 360 would be its negative. For here it says show that for any angle theta, if theta is between 0 and 90 degrees, that sine of that angle is equal to sine of 180 minus that angle. And it says show for any. I don't have to explain, I just have to show, which is nice, but I need to show for any, which means that I can't use numbers. I have to create the situation without any numbers. So I'm going to do the exact same thing we were doing up above, just now with no numbers. And it said that theta had to be between 0 and 90. So I might make an angle where this is theta. I might build my right triangle off of that. And then I'm going to call this 180 minus theta. I have to call things by variables. So I'm going to call this x. No, actually, I'm going to call this x, this y, and this z. So then we're talking about sine here. All of these values are positive because theta is less than 90 degrees. So here I would say sine of theta equals y over z. To continue this, I'm then going to reimagine this where this is now 180 minus theta, and then this is the right triangle we can draw from that, where this is now theta. We would still have an x distance here. I just made it to look bad, but it's still an x distance here, and then a y distance here, and a z distance here. The x distance is now negative, but we can see here that now that the sine of 180 minus theta is equal to still y over z. So those guys will always be equal to each other as long as your original angle is less than 90. Find two different angles, theta, such that sine of theta equals 0.65. There's a lot of different ways to do this. This way, I think, is the easiest. I'm going to first build a right triangle. With this angle theta. It's too small. And it says that sine of theta, which is opposite over hypotenuse, is equal to 0.65. So I'm going to label the opposite side length as 0.65 and the hypotenuse as 1. You could have done that a bunch of different ways. You could have labeled the opposite side as 65 and the hypotenuse as 100 to make the ratio turn into 0.65, but I think that just is too much work if you just do 0.65 over 1. And it says to solve for that angle. So that would be sine of theta equals 0.65, which means that sine, the inverse of sine of 0.65 is 40.54. And I know that the angle that completes this angle, the angle that is supplementary to this angle, would also have a sine value of that. So I just need to figure out what the supplement is to that guy, which means I literally just have to do 180 minus 40.54, which is 139.458. So the two angles are 40.5 degrees and 139 degrees. 3 sig figs on both of those guys. Show that in a triangle containing an obtuse interior angle theta and two enclosed side lengths with lengths A and B, the area given by the formula 1/2 AB sine of theta. Let's not do that one. I don't think that's important. And I would like to move on so you don't have to take up all of class today doing notes.